Here's question 8. We've got a box and we've got a lid. Let's think about the box first. We've got the height of the box is h, the width of the box is x, and the length of the box is double the width. As far as the lid is concerned, this must be 2x, this must be x, and this must be 3. You could argue that the lid won't fit over the box, but the odd millimetre here or there perhaps doesn't make any difference. Now we know that the box and the lid can be created from a piece of cardboard of area 5356 square centimetres. So let's work out the total surface area of the box first. The base of the box is a rectangle, 2x by x. So the area is 2x squared. The side there and that side there both got area x times h, and there's two of them, so it's 2xh, and then the front and the back have got area 2x times h and 2x times h. So 2x times h, 2xh, another 2xh, altogether that's 4xh. The box doesn't have a top. The top is the lid. So what about the surface area of the lid? The top has area 2x times x. The two sides here and here have area x times 3, so that's 3x plus 3x, so that's 6x. And then the front and the back have area 2x times 3, 2x times 3, so that's 6x plus 6x, that's 12x. Let's do a bit of simplifying. This becomes 2x squared plus 6xh, and the area becomes 2x squared plus 18x. So the total surface area becomes 4x squared plus 18x plus 6xh. And we're told that this equals 5356. So let's rearrange to make h the subject. So it's 5356 minus 4x squared minus 18x, all divided by 6x. Now the volume of the box, which is v, is the length, which was 2x, multiplied by the width, which was x, multiplied by the height, which is 3. So this equals 2x squared times 5356 minus 4x squared minus 18x, all over 6x. So one of those x's cancels with that. 2 over 6 is the same as 1 over 3. 2 is a factor of those terms inside the bracket, so let's take the 2 out. 3 at the bottom. So 2's into 5356 is 2, 6, 7, 8. And they've multiplied through by x. Let's put that 18x first. So it's 18x times by x, 18x squared. But I've taken 2 out as a factor, so that's 9x squared. And then I've got this 4x squared times through by x, so that's 4x cubed. Take 2 out as a factor, so that's 2x cubed, as required. Now we need to find the positive value for which v is stationary, so we need to work out dv by dx. So we need to differentiate that expression. The 2/3 can just stay as 2/3. Differentiate 2678x, it's 2678. Differentiate 9x squared, that's minus 18x. Differentiate 2x cubed, that's minus 6x squared. So dv by dx is 0. So if V is stationary, dV by dx equals 0. So in other words, 2678 minus 18x minus 6x squared is 0. Let's multiply everything through by minus 1, so 6x squared plus 18x minus 2678 is 0 times minus 1, which is 0. Clearly 2 is a factor, so let's simplify things slightly. 3x squared plus 9x minus 1339 equals 0. Let's plug that into the formula, because I don't think it factorises. Let's do that properly. X equals minus b plus or minus the square root of b squared minus 4 times 3 times 1339. Did you notice that I turned that minus into a plus there because of that minus sign here? The formula is minus 4ac, but that's a minus. And then it's all over 2a. And x is positive, so we're only going to get one solution, and it works out to be 19.68 to 2 decimal places. I asked for 2 decimal places in the question. Now, to show that this is a maximum value, we need to do d2v by dx squared. So we need to differentiate the expression we had before. So if I differentiate 2678, that's 0. Differentiate minus 18x, that's minus 18. Differentiate 6x squared, that's minus 12x. And if x is, what do we have, 19.68, d2v by dx squared is minus 18 minus 12 times 9.68, which is minus 254.16, which is negative. Therefore, this is a maximum. So this was part C. Part D, find this minimum value. So the value for V, if you remember, is 2/3 2678 minus 9x squared minus 2x cubed. Let's substitute x is 19.68 into there. So if x is 19.68, V works out to be 22648.7 cubic meters. And that's to 1 decimal place. Now for part E, the surface area of the lid is 2x squared plus 18x. So if x is 19.68, the surface area of the lid works out to be 1128.8. So the percentage for the lid is 1128.8 divided by the total surface area, 5, it's not the volume, it's 5356, and multiplied by 100, which works out to be 21.1% to 1 decimal place. Now question 9 is hypothesis testing. So the test statistic is the number of plates that are flawed. So we're going to be calling that x. And then the null hypothesis is going to be that p is 0.3. And the alternative hypothesis is going to be p is less than 0.3, where p is the probability that one plate is flawed. So it's going to be a one-tailed test, and the significance level is 5%. So we're going to have a binomial distribution. There's going to be 20 events because a sample of 20 plates is taken, and the probability that a plate is flawed is 0.3. So what we need to do is to find the probability that x is less than a particular value. If we take 2, works out to be 0.0355. I'm sort of guessing here. I've guessed 2, now I'm going to guess 3. 0.0355 is less than 5%. 0.1071 is greater than 5%. So less than or fewer than 2 plates, is so unusual that we can think that maybe this null hypothesis, this assumption was wrong. It's so unlikely to get 2 plates. Getting 3 plates is quite possible, that's more than 5%. So the critical region is x is less than or equal to 2. Critical region, that critical isn't terribly clear, is it? Anyway, it says critical region is x less than or equal to 2. Sorry about my writing there. Then the actual significance level at that point is simply the probability we've got, which is 0.0355. And then in a new sample, only one plate has flaws. If there's evidence that the process has improved, because 1 is in the critical region, there is evidence to support the claim.